First, that rock here with some math. Let's review the tangent wave for a minute. To do that, let's look at the unit circle for a minute. So I'll look at the unit circle. So tangent is defined as you put in an angle that's in standard position. It intersects the circle x squared plus y squared equals 1 at some point with x and y coordinates, and the tangent is the y coordinate divided by the x coordinate. So you put in the angle and you take out the intersection points ratio of the y coordinate divided by the x coordinate. So what do we get when we do that? Well, 0 divided by 1 is 0. Okay, and then if I put in pi 6, this divided by that gives me 1 over root 3, which is root 3 over 3. Something divided by itself is 1. If I put in pi thirds, I get root 3 over 2 cut in half, divided by half. Well, dividing into halves is the same as doubling. So I double this, I get the square root of 3. And then when I put in pi halves, I get 1 divided by 0, but that's undefined. So tangent doesn't have an output when the input is pi halves. But we learned in class that notice the y value is getting closer and closer to 1, while the x value is getting closer and closer to 0. And in that, so we know that the outputs are growing. So notice we went from 1 over root 3 to 1 to 1.7. They're growing and they get unboundedly large. Now going this way, if I rotate in the clockwise, that gives me negative angle. So at negative pi over 6, I'm going to get negative 1 over root 3, because the negative 1/2 divided by root 3 over 2 is a negative 1 over root 3, or negative root 3 over 3. And then this divided by that is negative 1, and this divided by that is negative root 3, and again I'm undefined. Okay, so that's a nice review. Now I want to point something out. So these angles, they look like this. So here's an initial side. We'll do the pi fourths angle. Okay, and this angle measurement is pi fourths radians. But how do you get radians? Well, you take the arc length and divide it by the radius. Well, the radius is 1, so whatever this arc length is divided by 1 is pi fourths. So this arc length, this length from here to here, is pi fourths units, whatever the units are. I don't know what the units are. If that's an inch, then if that's 1 inch, then this is pi fourths inches here. So the radian measure is equal to the arc length in the unit circle. Now what that means is you can think of tangent as being the inputs are the angle measures, okay? And then the outputs is this ratio, y over x ratio. That's the outputs. And the angle measures are the inputs. Or you can think of the inputs as the arc lengths, because the arc in the unit circles, because the arc length in the unit circle is equal to the radian measure of the angle measure. So they're one and the same thing, one and the same number, not the same thing, but the same number. So you could think of the inputs as arc lengths, and you get out the ratio of y over x using the xy coordinate where that arc length terminates. So this arc length terminates here at this point, and I take this divided by this, and I get 1. So that's pretty interesting, and we're going to return to that idea in a minute. But let's just graph the tangent wave. We should be able to graph a tangent wave now. So we'll bring back, whoop, that's the last page. This is the page I had. So we're going to graph a tangent wave. Remember, as we went to pi halves, the graph was going to infinity. The outputs were getting close to infinity as the inputs got close to pi halves. When the input was pi fourths, the output was 1. When the input was 0, it was 0. Negative pi fourths is negative 1. And then as we go to negative pi halves, it's going to be negative infinity. So we have a graph that looks like this. By now, y'all have all graphed a tangent wave a few times. And we realize that there's this coterminality, and this repetition of value. It doesn't even have to be coterminal, right? There's an angle over here at 5 pi over fourths. If I rotate all the way around to 5 pi over fourths, I'm going to get this point is negative 1 over square root of 2, comma negative 1 over the square root of 2. And so tangent, this divided by that is positive 1 again. So notice I get this output again that I got at just pi fourths, and they're not even coterminal. So over here at 5 pi fourths, I should have another 1. Oh yeah, that means this graph is repeating itself over here. Well, that was ugly. And then there's another one over here. And so it's doing the same thing, and there's an infinite number of them, of course. And they just keep going and going and going, because you can rotate around and around the circle. But in the game of finding the inverse function, we have to be careful. Notice this guy, if I put in pi fourths, I get out 1. If I put in 5 pi over fourths, I get out 1. Okay? So if this is the x and this is tan x. Okay? But if I want to invert that, when I put in 1, I need to get out 1 and only 1 output when I put in 1. So which one is it, this one or this one? Okay, well what we do is we choose this domain right here. We scratch out all of this and we say the domain will restrict to pi halves, negative pi halves is less than x, which is less than pi halves, when discussing inverse tangent. Okay, so we're only looking in here, so that means the output would be pi fourths. You do not choose 5 pi fourths as your output. Okay, so, and this notation is so awkward because students tend to think that means reciprocate, and sometimes it does, but not here it doesn't, that we come up with another name. We call it Arctan. And the reason for that is, remember, this could be thought of as an arc length. So you put in a number representing the y over x ratio at an intersection point, and this is the arc length that terminates at the intersection point that gave us that ratio. And so since it's an arc length, we call it arctan. So with that in mind, let's graph an arctan wave. So we have these points on our tangent, and we want to switch watch them. Inputs for outputs, 1 pi fourths, and then this is sort of like infinity, and then pi halves. So when I go out to infinity, I'm approaching pi halves. So there's a horizontal asymptote instead of a vertical asymptote. Oh yeah, if I had a vertical asymptote of x equals pi halves, well, when I invert, that's going to be y equals pi halves. So there's a horizontal asymptote. Then I have a point at 1 pi fourths, and -1 negative pi fourths, and then there's going to be an asymptote here for the same reason, and 0, 0. So the graph looks like this. And here is my arctangent function. Y equals arctan of x. Math made simple. Simpson math.